Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from a range of functions. And in this class, we are going to discuss this function, that is y is equal to f of x is equal to tan inverse x minus 1 over x square. Right? So here we'll find out the range of this function using some important concepts. Right? So let us start. So now to get the range of this function, that is we have to find the interval for y, right? Because x is known as a domain and y is the range. So here we have to find the interval in which y belongs to. Right. So to proceed further, what we will do will take this quantity, that is x minus 1 over x square, is equal to t, where t is some new variable, right? So here we have x minus 1 over x square is equal to t. So let us solve this equation for x, right? So here we can see that the highest degree of x is 2. So we are going to get a quadratic equation. So let us solve this equation. X minus 1 is equal to x square t, and we have x square t minus x plus 1 is equal to 0, right? So this is a quadratic equation in x. So now let us compare this equation with the standard quadratic equation, that is ax square plus bx plus c is equal to 0. So our a is t, b is minus 1, and c is equal to 1, right? And let us find out the discriminant of this equation. So we have b square minus 4ac, and we have minus 1 square 4 times t times 1. So this is 1 minus 4 times t, right? So this is the discriminant of this quadratic equation. So now let us come to our original function. So here we have y is equal to tan inverse x minus 1 over x square. So x minus 1 over x square is assumed to be t. So we have tan inverse t, right? So from here we can write t is equal to tan of y. Right now, from this function, we can conclude that the domain of tan inverse theta function is the set of all real numbers, right? So the function f of theta, that is tan inverse theta, has the domain as the set of all real numbers, right? So theta belongs to the set of real numbers. Now here this x has to be a real number, right? So x has to be a real number. So therefore from the quadratic formula, we can see that x is given by minus b plus minus square root of d over 2a. Now if we substitute the value of b, d and a, then we have 1 plus minus square root of 1 minus 4 times t, and here we have 2 times t, right? So the values of x are given by this expression in terms of t. Now see, x belongs to the set of real numbers. So it means this x has to be a real number. So for x to be a real number, this quantity, that is square root of 1 minus 4t, plays an important role. So our d must be greater than or equal to 0, because the roots of this equation should be real. So for real roots, the condition is discriminant should be greater than or equal to 0. So for this, we must have 1 minus 4t greater than or equal to 0. So we have minus 4t greater than or equal to 0 minus 1 minus 4t. We have minus 1, multiplying both sides by minus 1, the direction of inequality get reversed. So we have 4t less than or equal to 1. So t is less than or equal to 1 over 4, right? So now our t is equal to tangent of y. So here we can write tan y less than or equal to 1 by 4, right? Now taking the tan inverse of both sides, we get tan inverse of tan y, and then here we have tan inverse of 1 over 4. So here these two get cancelled due to the concept of principal value branch, or in other words we can also say that the tan inverse function is an increasing function, right, for all values of x belonging to the set of real numbers, right? So when we take the tan inverse of both sides, the direction of the inequality doesn't change, it remains the same. Because of this reason, that is tan inverse x is an increasing function, the derivative of tan inverse x is 1 over 1 plus x square, and 1 over 1 plus x square is always greater than 0 for all values of x belonging to the set of real numbers. So from here we get y, and here we have tan inverse 1 over 4, right? So the value of y is always less than or equal to tan inverse 1 over 4, right? So the value of y, it belongs to the interval that is minus infinity to tan inverse 1 over 4, and here this value is included, right? So this is the interval to which this y belongs to. So viewers, the range of this function is given by this interval, that is minus infinity to tan inverse 1 over 4. Hello viewers, in today's session we are going to discuss an important and conceptual problem from a range of functions, right? So here we have to solve this problem in which we have to find the range of the function f of x, which is equal to tan inverse 2x divided by 1 plus x square. So viewers, here we have an inverse function, that is tan inverse function, and to find out the range of this function, we have to make use of some important concepts. The first one is the domain of the function, that is tan inverse theta, right? And the second concept is the concept of increasing function, and we know that the function tan inverse theta is an increasing function for all values of theta. So here we can write for all theta belonging to the set of real numbers, right? So here tan inverse theta is an increasing function, because if we find the derivative of tan inverse theta, we'll get 1 over 1 plus theta square, and 1 over 1 plus theta square is always greater than 0 for all values of theta belonging to the set of real numbers. And the third concept is the concept of discriminant, because if we have a quadratic equation, say ax square plus bx plus c is equal to 0, then the roots of this equation are real if the discriminant is greater than or equal to 0, right? So the roots are real if b square minus 4ac is greater than or equal to 0. So here to find out the range of this function, we'll make use of these three important concepts, right? So let us start. So let us take the function y is equal to f of x, right? So from the definition of domain and range, we know that all the valid values of x are known as domain, that is all the values of x for which the function is defined, they all fall in the set of domain, and the value of y corresponding to some x constitutes our range, right? So we have to find all the values of y, or the interval in which the values of y will fall, right? So now here let us take one more substitution. So let us take t is equal to 2x over 1 plus x square, right? So now we can have y is equal to tan inverse of t, right? Okay, so now we'll proceed from this expression, and let us multiply, or let us get an equation in um, x as a quadratic equation. So we can now write t times 1 plus x square is equal to 2x. Then we have t plus tx square is equal to 2x. Now we have tx square minus 2x plus t is equal to 0, right? So now this is a quadratic equation in x, right? So here we have the equation. So now if we compare the coefficients, then we have a is equal to t, then b is equal to minus 2, and c is equal to t. So now let us calculate the discriminant of this quadratic equation, which is b square minus 4ac. So we have minus 2 square minus 4 times t. So this is 4, and here we have 4t square, right? So now we have the discriminant as 4 minus 4t square. Now here the value of x can be given by the quadratic formula, that is minus b plus minus square root of d over 2a, and we can easily see that the domain of this function, that is the values of x, are all real, because this quadratic equation has real roots, and for real roots we have d greater than or equal to 0, right? And in the original function we have y is equal to f of x is equal to tan inverse 2x over 1 plus x square. So the domain of this inverse tan function must be the set of real numbers, right? So the domain of tan inverse theta is the set of real numbers. So when the domain that is x is real, then the roots of this quadratic equation must be real. So d is greater than or equal to 0, and d is 4 minus 4t square greater than or equal to 0. Now here we can solve this inequality. Dividing both sides by 4, we have 1 minus t square greater than or equal to 0. So we have minus t square greater than or equal to 0 minus 1, taking this 1 to the right hand side. So now this is minus t square greater than or equal to minus 1. And now if we cancel these two negative signs, then the direction of the inequality get reversed. So we have t square less than or equal to 1, right? And 1 can be written as 1 square. So we have now t square less than or equal to 1 square, right? And this is a famous or well-known inequality. If we have t square less than or equal to a square, then the value of t goes from minus a to plus a, right? So here the value of a is 1. So we have t greater than or equal to minus 1, and here we have less than or equal to plus 1, right? So now we have this inequality, and from this relation we have t is equal to tangent of y, right? So taking t is equal to tangent of y, in this inequality we have -1 less than or equal to tan y, and here we have +1. Right? Now to get the value of y, what we will do, we'll take the tan inverse of all these three numbers. So taking the tan inverse of these three numbers, we have tan inverse of -1, then tan inverse of tan y, and then here we have tan inverse of 1, right? So now here tan inverse of -1 is equal to minus tan inverse of 1, and tan inverse of 1 is pi by 4, right? Because tan pi by 4 is equal to 1. So here we can write minus pi by 4, and here this tan and this tan inverse get cancelled due to the definition of principal value branch, and here we have y, and here tan inverse 1 is simply pi by 4, right? So viewers, our function was y is equal to tan inverse 2x over 1 plus x square, and this y is known as the range of the function, and we have obtained this relation, that is this inequality, y is greater than or equal to minus pi by 4, less than or equal to pi by 4. So the range of this function is given by this interval, that is from minus pi by 4 to pi by 4, right? So this is how we can find out the range of functions, and here we must explain the use of this concept, right? We have already used the concept number 1 and concept number 3, but here we have not explained this concept number 2, that is tan inverse theta is an increasing function, right? So let us see the use of this concept when we have taken the tan inverse of all these three numbers. So viewers, let us consider an inequality similar to this one, right? Here we have -1 and here we have 1. So let us take say minus a, and then we have say a tan of y, and here we have plus a, right? So what we have done here, we have taken the tan inverse of all these three numbers, and we have not changed the direction of the inequality, right? So when we have taken the tan inverse of these three numbers, the direction of the inequality remained the same, right? So this happens only when this tan inverse is an increasing function, right? So tan inverse theta has the derivative 1 over 1 plus theta square, and 1 over 1 plus theta square is always greater than 0, right? It means the derivative is positive for all values of theta belonging to the set of real numbers, right? So that's why whenever we take tan inverse of the numbers which are expressed like this, then the direction of the inequality remains the same, because the tan inverse function is an increasing function. So now to make it more clear, let us consider one more inequality, right? Suppose we have an inequality like this, that is minus a less than or equal to cot of y, right? So here instead of taking tan of y, we are taking cot of y, right? Now if we take the cot inverse of all these three numbers, then the direction of the inequality get reversed, right? So the moment we take the cot inverse of these three numbers, the direction of the inequality get reversed. So we'll write cot inverse minus a greater than or equal to cot inverse cot of y, and here we have cot inverse of a, right? So in this case, the direction of the inequality get reversed, because the cot function, that is cot theta, is a decreasing function, right? So cot function is a decreasing function because the derivative of cot theta is minus 1 over 1 plus theta square. And for all values of theta belonging to the set of real numbers, this expression is always going to be less than 0, right? So it means the derivative is less than 0, or it is negative, that is the slope is negative. So the function cot theta is a decreasing function for all values of theta belonging to the set of real numbers, right? So this is the concept which we have used in finding out the range of function.